I would like to begin with a collage that illustrates the two main approaches of my design. On the one hand, I had a region in the Campine Plateau, which is illustrated by the photo collage of the church and the city hall of Reyd. On the other hand, I had my fascination for fashion, illustrated by the sketches. While analyzing the water system in this region, I recognized some problems. The first problem is water pollution. On the right side of the Zuid-Willemsvaart, the streams are very polluted. This is because of the sewer overflows. The second problem contains water infiltration. The water can't infiltrate very well because of two main reasons. For one, there is the pavement of the city. Second, there is a heavy agricultural machinery on the many farmlands. These machines compact the soil due to their weight. But besides the water problem, there's also a big problem within the fashion industry. In this diagram, you can see the global fiber production in 2019. This industry is all about mass production, and cotton is a large part of it. The textile industry consumes enormous amounts of water for the production of cotton, among other things. The cotton plant grows in warm countries, so the water evaporates quickly. But because there is little rain, a lot of drinkable water is needed. The cotton for one t-shirt needs the water of 160 showers. So I started looking at alternatives for cotton, other plants that can be used to make textile, but that don't need so much water and/or pesticides in the process. There are a lot of options, like for example hemp, bamboo, or algae. I chose for the nettle, more specific the great nettle, which already grows in our climate. This plant is very versatile. It can be made into food, it's good for health, and it's an important host plant for caterpillars and butterflies. Bringing this all together, there's a first solution to the water problem. The wastewater of the city will not be dumped into the streams, but it will be used for the nettle fields. The plants will absorb the nutrients and purify the water before it infiltrates or goes to the factory. The second solution consists of a path that runs between the nettle fields. In this way, the soil will only be compacted at the place of the path and not everywhere. On the path will drive a verge mower with an arm with a reach of 6 meters. This was therefore the determining distance for the nettle fields. Next, my research went further into the nettle process. It starts by growing nettles, which are then mowed and collected in straw bales so that they can be combed afterwards. The plants then need to rot, similar to the biofermentation process, which separates the fiber from the stem. After a wash, the fibers can be spun and sewn. At the start of the process, cuttings are taken in early spring. These are multiplied in the field and then planted in the summer, around July-August. From the second year onwards, the plants can be mowed and combed in summer so that they can rot during autumn. From December, the fibers can be processed into clothing. The concept of my project is that the wastewater from the village of Beek is purified by following a road through the nettle fields. This purified water will partly infiltrate and partly continue into the water storage of the factory, where it can be used for the textile process. After it has been used, the water will be directed to the stream. The project, located on the edge of the city of Bree, has been specifically designed for this place. Nevertheless, it functions as a pilot project that can be developed in various places on the Campines Plateau and even beyond. On this plan, you can see an overview of the various landscape and architectural components of the process. The nettle fields in the northwest on higher ground, the water storage attached to the factory in the south on lower ground. The factory is located on an already existing industrial estate. Here you can see better how one long winding path runs between the nettle fields, just like the narrow irrigation streams through which the nutrient-rich water flows. It also shows how the path, the pavement around the factory, and the existing towpath along the canal are connected. This conceptual illustration of the water system shows the path the water takes through the project. The wastewater that was purified by the nettles is collected in the water storage together with the rainwater that is collected on the pavement of the factory. This water can be used in the textile process and then dumped into the stream. On this overview image, you can see how it would look like standing between the factory and the water storage, facing the nettle fields. This section emphasizes the scale of the factory and the water storage. The factory is 26 meters by 10 meters. The water storage has a length of 48.5 meters and a depth of 2.5 meters. It's a volume of almost 2,500 cubic meters. Here you can see a more zoomed in section that shows the nettle fields, the irrigation system, the stream and the factory. To end, I would like to show you this mood image.